created a little noises related to the fan of my laptop. If you and as you used to it, about it. So speak louder. The number of for the first class is 36. But now the attendance here 14. Yeah, Muhammad Rashid Mahdi. CPU fan. I don't know why, but it is related to my system. From the I bought this laptop, this is with here. It's with it. I used to it, and other students also used to this voice. They know that my laptop has this voice. I don't know. It is Sony. It is a Vaio. The brand is okay, but really I don't know why. Of course, it is better. I show my laptop and to the expert. Maybe there are some problems. I don't know why. And finally, Naima comes to class. Okay, now it is okay. Another thing besides the sound of my fan is related to the speed of your net. For instance, sometimes some students said that my voice is not clear and it has some interrupts. It also related to your internet. It's not related all to me. Okay. I wanted to record another video for the previous sessions, but I preferred start to a new topic, and then after that I will record the remain for your offline class. Okay. If you don't have any question, we start teaching. Oh. Thanks for reminding me to record session. Surely. Okay. In the name of God, we start the third session for our course. As you see in the previous session, and it will be taught about the fundamental of machine learning. And we explain some phrases, some words in this field. For unsupervised learning, reinforcement learning, validation, cross-validation, training, batch online office system, and like this. And now, from this session, we want to start some algorithm field. And as you see here, our main topic is computational methods for data analysis. If you remember at the first session, we said something in it. We said, for example, linear singular value decomposition, CAN, and blah blah blah. Okay? And as you see, in its main topic, I mean computational methods for data analysis, we want to discuss about the frequency analysis. And we want to and waves. As an engineer, you know the Fourier transforms. At least you hear about it. You have heard about Fourier transforms. You know about. We want to learn more about the context. We see some examples for Fourier transform. Okay. Then our way in this session is time frequency. Studying about the time frequency. And the reference of this course, of this session is reference C. I opened it. I uploaded this in the LMS. Reference C, part 3, computational methods for data analysis. And chapter 13, time frequency analysis. We are here. If you want to know more and to study the details, you can follow this chapter. Chapter 13. Okay. And now we started. In engineering mathematics course, you saw if we have a periodic function, if we have 2 pi periodic function, I mean if we have f(x) plus pi is equal to f(x), we said that this f(x) is periodic with the period of 2 pi. Okay, and we in that course that we can represent this f(x), and in real we can represent it with a constant plus a series of sinus and cosine and sinus. Okay, and if you attention to this equation, you see that this periodic function cosine and sinus has some coefficients, and we calculate we can calculate this. Okay, for instance, a 0 for this function is like this. Can calculate this. Okay. I again remind you that I'm mouse. Then if my handwriting is not so good, it is because of this. Okay. And then after that, we said that all periodic functions don't have period. Maybe the periodic, two, I miss. Maybe we have two with a generic duration. In this way, again, some real presentation of Fourier. Besides, we can represent Fourier series in complex version like this. For instance, fx exponential function, and the power of this is I and px alone. The periodic is here. Related, we have some properties in this field. For example, if was real, was real, then Cn or C minus n is equal to C can improve it. I don't know you see this before or not. But we can improve it. Besides, if we have FAX real example, function, you know, even function. If you know, please type it. Button. Okay. This one you know, you forgot it. This function, like this. This function is even. The symmetry of this function is related to the vertical line. And if you f minus x is equal to fx, we call this function f even odd. F odd, the shape of f odd is like here. I write it here. This function is related to the central point to 0. And if you remember, f minus x is equal to minus fx. And this function is even. Okay? Okay. Anyway, if our function was real and even, what is real? Real means a function doesn't have imaginary part. All the things, all the measurements in this fx is real. Imaginary part. Okay? And if our function was real and our Fourier coefficient is even. Real and even, like for even, we can write this. For, let's say that the conjugate of Cn is equal. And if real and odd, and odd, the Cn would be complete. It means questions. No question. No. Okay. We know these things. I hope you to know always. This is Fourier space, is Fourier environment. If we call it f is dependent, and if we transform the function to the Fourier space, the function is related to frequency. And why we use Fourier transform? What is the advantages of Fourier transform? Image processing. In signal processing, the information is represented is better presented in Fourier space. Okay? Some information, then in summary, information Fourier space is better represented. Okay? Then we use this transforming this function. to the Fourier transform. After that, who names Coulomb and Touquet is commonly Fourier transform, and they transform, and this type also has some advantages. See the advantages in the next slide. But before it, we use the application, one application of fast Fourier transform. Please imagine it in a cylinder here, okay? This cylinder sends for instance, electromagnetic. Try to detect it. For instance, try to detect this airplane. It sends electromagnetic to target, and the target reflectives also has one part of reflect this time and receiving it. This radar, this object can understand the place of this target, or can understand this target, can track ideal. In the real world, we have clothes, we have trees, we have other targets. The target on it. We have that they also may reflect the electromagnetic receiving the received waves here is not related only to others. Then we receive electromagnetic wave here. Okay? And from this system, simple system, we can use or set other example. For example, stealth technology or radar jamming system. Sometimes attention to this, the above other the shape of target specific and doesn't go to the target reflect waves to other directions, as you see here. Main materials of target, the materials of target was special. Then instead of reflection, it observed all the waves. We cannot track the target in this way or in this way. Okay? And another thing is a jamming system. For instance, you imagine an airplane was desired object. The radar sent wave, but another fake target, another fake aim, same way to, and then this way we confused what is the object, what is the main one or two target. Then we called it parasite. Okay. Then in both we want to we can use Fourier transform. How? In the next slide you see. Have any questions? Yes, surely. Surely today I uploaded. Okay, another question. Yasmin said no sound, but I think this okay. I think this okay. Maybe it is related to your internet. Okay. Okay. We have a noise like this. Okay. We want to noisy signal system. Okay. We want to track the main signal without any noise. Then we want to if we use the Gaussian filter like this, third center frequency. If we want noisy signal in the Fourier space, and then if we use inverse Fourier transform, if we use inverse Fourier transform, we achieve this pink. Signal. If this pink signal is our original signal, is near to each other. It is not less but and it is acceptable for us. And on the other hand, on the right figures wrong. For example, we again use this Gaussian 0.2, but it's after filtration in the inverse we have this blue signal. Okay, and it is clear that this blue is far from the origin. Then choosing the parameter entering in, and another thing from this example in the Fourier domain, we can noise. Then one is the signal. For example, this example. Don't question. For this application, for instance, if you have some signal in Fourier transform, and in A it is one signal, B is the average two signal in Fourier domain, C and is the average of 100 Fourier domain. It is clear we have a number of signals and we average them. All result is better. It is related to the noise, the kind of and the noise. Because here the noise is white. The center of noise, the frequency of noise is 0. Then by averaging in frequency domain, we can read them. Another advantages or another application in this field. In contrast to this example in the left, consider this figure, right upper. We have many signal shape this. We have noise for each signal in time domain, and if we use Fourier transform, we have here. You see in the Fourier transform the location of noise missed. All the Fourier transform of these above signals has the same, you see, noise in Fourier. And we cannot distinguish between, for example, 1 and 2. If we use Fourier transform really only with this, we cannot relate one with this signal or this signal or another signal. This is the disadvantages of the Fourier transform cannot distinguish the location some frequency. And this is another application of fast Fourier transform. The above figure shows that the average in the time averaging in Fourier is better than the in time domain the information lost. But in domain in frequency, the noise can be observable, can be detectable. Okay? The code is the explanation of this thing. Is complete the code and achieve this diagram that I explained. Okay. Okay. In summary, frequency. It is in domain. And if we use Fourier transform figure, for example, if I zoom on it, consider this figure, and attention to the changes. Time changes can be reflected by frequency. Changes can be reflected by frequency. I mean, for example, imagine this signal and imagine this signal. Both of them in time. Finally, one student type something. Please let me read it. Frequency we call the frequency above signal F1. The frequency of the lower signal F2. Which of them is higher? F2. Please type frequency above signal lower. Thanks. Ms. Ali Abdul Abbas Hussain correctly said that the second. Yeah, it is correct. Frequency means changes. I will answer you. Safa Abdul Jalil Tawil, I will explain. Please wait. Okay. is. Now the signal is lie on this pink. Besides, we have changes here. If we called it F1, F1 of these changes here in this part is greater, for instance, if we call it A, we called it B. F1 is higher than A is higher. The changes signal. Okay. We also said, okay, we have some frequency error 0 here. Maybe this is related to this ping. Have this frequency F1, maybe it is related here. I wanted to say that by using Fourier transform, we can access only the amount of frequency. But we cannot say, okay, if one in the first of the signal, we cannot of F1. By Fourier transform, says the frequency context to the frequency signals. And then the disadvantages of Fourier is that what is the Fourier transform good? Advantages, benefit of using Fourier transform. Why we use Fourier transform? Please consider two signals in left and right. As you see in right, change in signal. But these changes repeated. After duration time is repeated. Okay? And consider the left signal. We have some changes here. Then the changer is higher. Then again higher than the previous parts. Okay? The frequency content, the frequency information in the left changes during time. The frequency information changes. Right? The context, the frequency changes and repeat it again. Then, but not still, we trans good fab signal, but is not good for the left. Consider Fourier transform now. Again, we see that, okay, 50, 100, and 100 ampere, these two Fourier transform are similar to each other. We called the right signals stationary station signal the signal with frequency content unchanged in time. But in the left, we have non-stationary signal. And ultimately, the Fourier pair, as they are unchanged during time. But it's not proper non-stationary signal. Our bio system, if we use for heart, our human heart, we called it ECG. Electrical signal of head, we call the EEG. They are non-stationary signal. Then we need some other for the for analyzing of this non-stationary signal. Okay. If you don't have any question, we stop till slide 11, and the remain was for offline that I will record it and MS. That Muhammad Rashid asked many questions. No, this is related for advanced algorithm. But in DSP, I also teach DSP. In DSP, we have discrete Fourier transform. And discrete Fourier transform is a little different from this. The formulation, the concept is different. Introduction of Fourier transform, they are common for both of them, DSP and advanced algorithm. Oh, okay. It is good. Recommendation. Yes. He said that we upload the PDF before the session. Okay, why not? I will next session. And Safa Abdul Jalil will ask, we depend on the book or slides, both of them. The PowerPoint, the slides, is the abstract of book. Then you please first see the slides and things, what is the important context, and then after that you can study in it by book. For instance, we review and we abstracted with only 10 slides. Okay? Okay. Any other questions? Okay. We don't finish this. Session. Thanks for your attention. I hope to be fine. And I said goodbye for all of you. Bye. Bye.